Hello, my name is Ana Melissa Lopez Hernandez, and this is the project process part 2, and this is the practice number 4. The name of this practice is frames. In this practice, I will talk about the reference system that is set directly on the tool used by the robot. Its main function is to allow the robot to perform precision movements, always considering the position and orientation of the tool. When the tool is changed, the tool frame must also be adjusted to ensure that the robot continues to operate accurately and efficiently. Well, the use of the frames, it's about the ubication and orientation of the position. The ubication and disposition express about the three different dimensions, about the direction X, Y, and Z, and the orientation and disposition express like three different dimensions. Uh, this expressed in degrees about the X, Y, and Z axis, and in the manual express that have three different type of frames. It's the one is the world. This frame it's the predetermined to the robot, and the second is tool frame. This frame is defined about the user, and the third frame it's about defined for user. Well, where the frames are essential for the programming and control of industrial robots as they enable pressure movements and optimize the robot's interaction with this environment. Well, the world frame it's a global and fixed coordinate system of a robot. Its serves as the main reference for defined position and movements within the workspace. Uh, we have the tool frame. This frame it's mainly used to define and adjust the position and orientation of the tool in relation to the robot. And current movements during applications such as welding, painting, sealing, or hauling. And we have the user frame. This reference system used for all positional data recommended in a program. Its main function is to allow the compensation and adjustment of position without the need to directly modulate the program. It can be defined in any location, making it easy to adapt the robot to different work environments. Well, we have some precautions. Whenever you create a program, you must assign it a user frame with a number between 1 and 6. If you don't plan to use it, even if you want to use your frame to be a origin in a coordinate to 0, you must set it. If you don't, and the programming tries to use a different user frame, while the current number is 0, the program will not work correctly. Well, we have two different types to the tools, and the first one is the simple tool. A simple tool is one in which the main working direction it's aligned with the z-axis on the tools by default. This means that when the tools moves in the direction of z-axis, the application point follows the same direction within the motion. And another one, we have the complex tools. This complex tool is one of the which its axis of attack is not aligned with the z-axis of the tool by default. This means that the tool orientation must be adjusted or compensate for in order to the robot performs accurate movements. And then we have some steps to do the configuration user tools by the method of 6 points. And this is the all of the steps, and the steps say that we have to do and a point to referentials, and well, open the simulator to do this. Okay, when we open this simulator, the first thing that we have to do, it's a configuration of the methods, and press the menu, setup, frame. So all the frames that the robot have, and select one frame that work in F, and in my case, I select the frame number 1, and press detail. Okay, then I comment this tool, and as the comment, and then keyboard, and name this tool. Okay, it's input the first point of approximation. Before this video, I searched all the coordinates about the point number 1, 2, and 3, about the different approximation in the manual say that we have to search, and I have the coordinates about this. And the first approach point 1, open the current position and put the coordinates that I searched before. 42 in the axis G1, 42.65 minus 12.643. In the G2, 30.04. And the G5 minus 68.650. And the G3, 4.281. And the G6, 17.866. Okay, as you see, the first point position, it's about the parallel with this object, and the other thing that we have to do, move to the first point is when the first point is approximation, press the main shift and the press record, shift, record, and this point recorded. Okay, then the same things in the second approximation. Um, 49.3 minus 66, 0. And press the move to. And in this approximation, it's rotated about 90 degrees. And the same steps in the other position. Shift and move to and record. Okay, and the third point, you put the coordinate 49.57 and press the move to. And this is the change of the position in the third point. And do the same things, shift and record. And in this position, we have the third point recorded. And in the orientation point, it's the same coordinates at the approach point number 1. And press the point number 1 and move to. And this the robot move to the point number 1 to save in the orientation point. And recording in an orientation point, and the direction point in about the axis X, it's about the coordinate in a word, change the world, and move to in the X axis. And the Z direction point. And record this. Well, this is all for this configuration to the 6th point.